Hey, all right, geometry students, welcome to the exercises for 2.3 on deductive reasoning. The full problem set is page 91, 1 through 17, 21, 23, and 33 odd. I'm going to be doing 1, 3, 5, 7, 15, and 17. So I've got a good spread of these. Hopefully you're enjoying this chapter. As a slight change of pace from all the algebra in chapter 1. Those of you who don't like writing, maybe you don't like it so much. But all right, here we go. Question number 1 asks, explain how deductive reasoning differs from inductive reasoning. And I just want to cover this one to emphasize the difference. And that is you have inductive reasoning. Oh, let's get our answer ready. Inductive reasoning is based on patterns. Okay, patterns, observations. So that is where I gave the example in the other video where if I have the conclusion that people are not watching these geometry videos, and if I conclude that because I've taught for multiple years and I can see that students rarely want to take time, each year I see students don't really want to take time to watch the videos. They just want to rush through their homework. They just want to copy off their friends. They just want to get through it as quickly as possible rather than sit down and learn it well. That's me drawing the conclusion that nobody wants to do their work or nobody's watching the videos because it's never happened before in the past. And so I'm following a pattern of behavior or past observations. Whereas deductive reasoning is based upon evidence, facts, properties, and definitions. Whoop, it's a little sloppy. Definitions, or you could even say conditional statements, which that's pretty much what we'll be doing in this chapter. So if you see an if P then Q statement, that is deductive reasoning. If you see a pattern of numbers, then that is a inductive reasoning. And so like going back to the example, people aren't watching the geometry videos. If I'm basing that upon the fact that I'm looking at the YouTube channel and I'm seeing that there are not very many views and there's not nearly as many views as there are students in the class, then that tells me deductively that the videos are not being watched. So one's based on patterns, one's based on facts, properties, definitions, and conditional statements. Okay, question number 2. So hopefully these videos can help. All right, actually not number 2. Getting distracted by how fun math is. Question 3 asks us to, does each conclusion use inductive or deductive reasoning? So we're practicing telling the difference. Question 3 says, a detective learns that his main suspect was out of town the day of the crime. He concludes that the suspect is innocent. Okay, this is probably sounds like a typical piece of crime evidence, but notice there's no pattern. There's no, because this happened in the past or because they looked at what came before, excuse me, that would be inductive reasoning. But because there's a simple fact that if the person was out of town, then they could not have completed the crime. This person was out of town, therefore they must be innocent. So this is an example of deductive reasoning, because you could quickly turn it into a if-then statement in order to explain your reasoning. And again, look for it, but just remember, lack of pattern is a clear sign of that. Okay, so let's take a look at number 5. All right, number 5. And again, always read the black instructions above these, or else you might just read number 5 and be like, what am I supposed to do with this? The instructions say, determine if the conjecture is valid based on the law of detachment. And just to remind you, the law of detachment said we have to look for a if P, then Q statement, and they have to tell us P is true. They can't tell us P is not true. They can't tell us Q is true. They have to tell us P is true. So let's look at number 5. If the side lengths of a rectangle are 3 and 4, then the area is 12 feet. So there's our if-then statement. A rectangle has side lengths of 3 and 4 feet. Okay, so they gave us P and Q, and then they gave us that P is true. So can we conclude then that the area of the triangle is 12 feet squared? Yes, this is valid because they met. And we can go ahead and box our inductive reasoning up here. because they did this, and you have to be very literal in this. If this, then this is true, therefore this is true. It kind of seems basic, but they're going to throw curveballs at you and say like if P then Q, not P. Don't fall for it. Don't say any. Doesn't mean anything about Q. Or if they say if P then Q, Q is true. Don't say anything about P. It's got to be as basic as we've said it over and over again. And this one does that. Follows the pattern exactly. All right, number 7. Let's take a look at that. Pleasure doing homework with you today. Number 7, determine if each conjecture is valid based on the law of syllogism. Okay, so that is where we should be able to see P, if P then Q, if Q then R, therefore, those 3 little dots mean therefore, if P then R. So let's see if that pattern is apparent in number 7. It says if a figure is a square, then it's a rectangle. If it is a square, then it is a parallelogram. And then they give us the conjecture. Notice right away I'm skeptical, because notice you should have this crossover of whatever the conclusion is here should be the hypothesis here. If we read it, they say if a figure is a square, then the figure is a rectangle. So I would expect the next hypothesis to be something about a rectangle, but instead they say if a figure is a square, then it's a parallelogram. They actually their pattern is something more like this: if P then Q, and then they say if P then R, because they repeat that thing about the square. And then they say if a figure is a parallelogram, then it's a rectangle. So then they sit there and go, okay, basically if R, then Q. They're using all the same words, but notice it doesn't follow the right pattern. And so this is not valid. I'm sorry. This logically a train wreck, because they did not follow the pattern. You have to build it. P to Q, Q to R, say P. Then that triggers R down here. Again, what they state is more like what's in the blue, and there's no logical pattern to following that to any sort of conclusion. So, and sometimes if it helps, diagram it out like I just did. Okay, we're going to do, that was number 7, 2 more, 15 and 17. Okay, use the true statements below for exercises 15 through 18. So we're going to be using the same statements as before. Determine whether each conclusion is valid. Alrighty, so let's read the statements. The top thrill dragster at Cedar Point Amusement Park. The top thrill dragster is at Cedar Point Amusement Park. So first thing they do is they tell us that this, I'm just going to draw some basic notes. Top thrill equals or leads to means that you're in, we'll just say Ohio, Sandusky, Ohio. Then number 1 says Carter and Mary go to, well, maybe we'll say it, go to Cedar Point. So Carter and Mary go to Ohio. Well, we should say Cedar Point. Okay, and the third one says the top thrill dragster roller coaster reaches speeds of 120 miles an hour. So that's saying if top thrill, then you're going to go 120 miles an hour. I'm just trying to lay out these statements. The last one says when Carter goes to an amusement park, he goes on all the roller coasters. So if it's Carter, then he is going all coasters. Okay, we could probably clean this up a little bit. Well, actually, no. Notice the second one doesn't have the arrow, because that's more of a statement of what's happening. It's not an if this, then that. It doesn't say if Carter and Mary go somewhere, then it's Cedar Point. That's kind of like the P is true part. That's kind of like the trigger, I call it. It triggers, now that we know they're going to Cedar Point, we'll see what else we can conclude. So let's look at 15. 15 says, can we conclude that Carter went to Sandusky, Ohio? Well, it says in number 1 that Cedar Point Amusement Park is in Sandusky, Ohio. So if they went to, and we know for sure they went to Cedar Point, so therefore that must be valid because it's part of the statement. So that is number 15 is valid. Oops. If you want to explain it, you can just say Cedar Point is in Sandusky, Ohio. Okay. Because they stated that and it fits in where the roller coaster is. Okay, number 17 then says Carter rode a roller coaster that travels 120 miles an hour. So, do we know that he actually went 120 miles an hour? Well, let's look at our statements. We know that he went to Cedar Point. So then we know that if he goes to an amusement park, he rides, if Carter goes to an amusement park, he rides on all the coasters. And therefore, if he goes on all coasters, that means he went on Top Thrill, and Top Thrill goes 120 miles an hour. So this statement triggers this idea or conditional, and then this conditional triggers this one here. And so we can, from Carter going to Cedar Point, we can know that he got on all the coasters, therefore he went on Top Thrill, therefore he went 120 miles an hour. So we can say that is also valid. And again, if you want to write that out, you can explain it, but that's okay. We're gonna, well, I made the video, you can cut me off if you're bored. But yeah, we got Carter went to Cedar Point, or I shouldn't say that, put the arrows there, let's go. We know Carter went to CP. That means that he went on the coasters, which means he went on Top Thrill. I'll abbreviate that, Top Thrill, which means he went 120 miles an hour. So you have to be able to follow the chain of logic according to the statements they give you to know if in fact the statement is valid. Okay, takes a little bit of practice. Work through the rest of the assignment, and again, reach out. We'll be reviewing a lot of this on Thursday, but reach out earlier if you have more questions. But again, be very careful and precise in your language because it can be very easy to kind of mush everything together. And because some of the words are all the same, you just kind of think, yeah, that makes sense, and you say it's valid. No, you got to be able to track it, P to Q, Q to R, therefore P to R, or something like that. All right, talk to you soon.